In this next tutorial, we will apply correlation analysis to identify products that are most likely bought together in a store.
Product affinity analysis provides insights into what customers purchase together in a transaction or in a shopping trip. Insights from this analysis may be used to come up with product bundling strategies or inform store layout optimization. In this example, we are given a transactions dataset with transaction IDs and the different products purchased in the same IDs. Now, to perform product affinity analysis, we first need to process the data in such a way that we have transaction IDs for rows and products as columns. To do that, we will use pivot table. So as you can see, we already have the pivot table in this section. So just simply right-click on the pivot table, choose pivot table, or rather show field list. And then let's drag transaction ID to rows, and then product to columns. Now for values, let's drag transaction ID to values. Now, transaction ID is a nominal variable. So taking a sum of transaction ID does not make any sense. So what we'll need to do is to change the aggregation from sum to count, because what we want to get is the count of each product in a transaction. So to do that, just right-click on any cell within the pivot table, choose Summarize the Values By, and then select Count. Now you can see that the pivot table already reflects the structure that we'll need for the subsequent product affinity analysis. Now, let's just fill all the blanks with zeros. So to do that, just right-click again on the pivot table, choose Pivot Table Options, and then under the Layout and Format tab, just type in 0 under this option. For empty cells, show 0. Click OK. So now we have a table of binary variables where for each column, if the value is 0, then for that particular transaction, that product had not been purchased, and its value becomes 1 when that purchase of that particular product happened for that particular transaction. Association between binary variables is called phi correlation. You can compute phi, phi, by using the Excel function Pearson. So to demonstrate how you can derive the fee coefficient between two products. So for this first cell in this affinity matrix, so the correlation between product A and product A, let's just type Pearson. Then for array 1, let's select everything under column A. Press F4 or function F4 to fix the reference. And then again, let's select everything under product A. Then let's press F4 twice. Then close parenthesis. Now, note that we pressed F4 or function F4 twice here in the second argument of the Pearson function. And this is because we want to be able to move the column reference later on as we copy the formula sidewards. So now that we have correctly specified the formula for this one, let's just press enter. Now, notice in our affinity matrix that the diagonals are all equal to 1. The diagonals correspond to the correlation of a product with itself. That's why the value, or rather the values, are equal to 1. So now that we have correctly specified the formula for the diagonals, let's just copy the formula sidewards. So let's do it by row. So just follow me as I copy and paste the formulas. Just 2 more rows to go. So now we already have a matrix quantifying the affinities or association between the different products. Now, while it's good that we already have the phi correlations or phi coefficients in this matrix, it's better if we can format this table in such a way that it'll be more intuitive for the user of the report or the decision maker to quickly identify products that go together in a transaction or that customers purchase together in a store. So to do that, we can make use of conditional formatting. So while the cells are highlighted, just click on conditional formatting. Then let's choose color scales. Let's just select the first one. So compared to how it looked like before we formatted the table, that this table looks more intuitive. In affinity analysis, the absolute strength of the association between the products is usually less important than the relative strength. So near zero correlations mean that customers have so far shown no purchasing affinity with the other products. Negative correlations mean that customers who purchase one item are less likely to purchase the other. Conversely, positive correlations mean that customers who purchase one item are more likely to purchase the other. So in our example, we can see that customers usually buy or purchase product B with product G in the same transaction or in the same basket.